Today we introduce the HTGK-III circuit breaker analyzer. This tester is used to measure the characteristic parameters of the SF6 switch and the outdoor switch. First, we see the wiring. The wiring plate is such a square switch which connects three lines of red, yellow, and green to the contact of the device. The black line shortens the below contacts and leads to a line. So far, red, yellow, green, and black are connected to the A1, B1, C1, or A2, B2, C2 of the instrument panel and to the other two ports, and then connect secondary control voltage line. The secondary control voltage is on the port of the control power on the panel. The matched red, green, and black three wires connect to the secondary terminal. Sensor installation. There is a magnet at the bottom of the sensor. Universal head part connecting magnet. If the field is not convenient, use rear sensor to connect the arm of the switch. Both installation methods are okay. It only needs to change to the corresponding sensor in the setting software. The sensor signal line is connected to the signal port on the instrument panel. If field test needs external trigger, only needs to pull out the power socket. The external trigger dedicated test line is connected to the external trigger of the instrument panel, and the other end is connected to the action voltage terminal of the switch. Change the mode of the internal trigger, external trigger from the software. Now let's introduce the use of tester. First, we power on, then set test parameters before test. We go into Set menu, Test Set. The first is velocity, which is based on some of the manufacturers that are already set in advance in our instrument. The velocity is set according to the actual switch value of the manufacturer. We choose the regular 10 Ms here. Then the second is sensor position. According to the actual installation location, there are A, B, C, three-phase, and automatic. Now our sensor is installed at A. We choose A. The third is time scope. We can set up 250 ms, 500 ms, and the max 4 seconds on the basis of actual. Here we choose 250 ms. The fourth is prep time. Here we do not need to store energy, so we set it to 0 ms. The fifth is trigger mode, which is divided into internal and external. The internal trigger is based on the power of the internal power of the instrument. The external trigger is based on the external power supply, AC or DC 220V, to external trigger interface and dedicated test line. Here, choose internal trigger. The sixth is type of sensor. The first is omnipotent sensor, which is an optional accessory. The second is real sensor, and the third is linear sensor. The real sensor is installed in the position of the switch arm, and the linear sensor is installed under the switch contact. Here, we install the linear sensor. So, we choose the linear sensor. The 7th, 8th item below is the measure, and we choose the enable state. The 9th is travel. According to the value of the sensor to set up a normal value. Here, our sensor is 50 mm. Test voltage 220 V. After setting the above, we press Confirm to save. After setting, we are now starting to test. First, we choose Close or Open according to the current status of the switch. If in open position, do Close test. In close position, do Open test. Now the switch is in the open position. We do the close test. Again, confirm test is set correctly. We press Enter to start the test. Being tested. Normally, after switch acted, the screen will show action time and related speed curves and current curves. Press will see the action time of the A, B, and C phases, and then automatically calculate the 3 phases synchronized according to the maximum and minimum difference. Here, the synchronism of the switch is 1.4. Below have some detailed parameters, such as close V, max V, and coil current. Now the switch is in the close position. We do open test. After reconfirmation that the parameters are correct, we press Confirm and begin open test. The instrument shows the result after the switch action. Press, which also shows the synchronism of opening max V and coil current. Here the 3 phases synchronism is 0.4, the speed of the trip and the coil current. Then the other is the view and print. We press Print. The instrument prints all the data. The use of the instrument is introduced here. Finally, we talk the attention in the use of the instrument. On site, the ground line is connected to the ground column, and the other end is grounded to the earth to ensure effective grounding. The output of our instrument control power cannot be short, wrong, or reverse connection. If the fuse of the instrument panel was burned due to incorrect operation on site, please replace the same type of fuse.